Hi and welcome to the fourth episode of Just C++. Today it's about refactoring, and we're refactoring the pool class from the last episode. I know the code I showed there wasn't that perfect, and I don't want to make this show only about perfect code, so every now and then you're gonna see some code which isn't that perfect. And in the last episode you could see a little bit of dead code, things which are commented out, things how this class evolved, and what things I tried and how things got refactored. And this evolution of code, sometimes it's interesting to see, and that's why I wanted to show that to you. But also knew that at some point I had to refactor that class, and well, having that code on YouTube is a huge motivator, and so I did take the time today to do that. And here we already see the old class, and I quickly want to go over what I refactored. So if you remember, the first episode of this series was about generic code, and I was like, well, if you use something twice, or if you have like if you have certain code and you use it a second time, or you reuse it a second time, that's a strong motivator to go for a generic solution. And that's what I did today. And the strong motivator here was basically, you can see those using declarations, which are then at the same thing here, just that I'm switching out the type here. With a one-time shape predictor and one-time frontal face detector. And this could be half the code if we put it in a template. Then if you go further down, the string streams and the future, these are things which I currently have not refactored. I could just, but to me this is like implementation specific, and I don't want to refactor that in generic code yet. Then again, all this could be halved, and I don't need two mutexes. I have like one mutex in the actual template, and of course all the free functions are also replaced in the actual template, which we're going to see. And what was very important to me is that I'm able to keep the interface as it is today. I don't want to refactor my application code. I want to refactor this class and have a generic solution which I can later reuse in different applications, or in this application for a different need. If we go above, this is the actual face detection pool class, which uses the actual pool service. Well, yeah, naming things is hard, and I just went for pool service in this case, which is a template providing a pool, and we declared two different objects of them here, one's for the face detector and one for the shape predictor. And the interesting things are actually happening here in the pool service. So first we again need this deleter, which is then part of the unique pointer, and this needs to be public because if I go back into the actual implementation of the class using it, this is what we have to return from our public interface. And so I can just expose this return type to the actual user. That's why this is public. And then these are then private. This is just the my pool, which is the container, which is a vector of the unique pointer. Then again I have the free iterator, which is basically the iterator which shows the first object which is available to return if we have an object which we can reuse, or if the pool does not have a free object, then that is the end iterator. As we see, this is like also in the beginning, and the class has an std mutex to make sure that all the accesses to the pool and the free iterator are properly locked, because this pool is of course called in multi-threaded code. That's the purpose of the pool, to be executed and tasked. And this is the class which actually returns a pointer. I call it receive pointer. Again, naming things is hard. One thing which made me a little bit think on how to solve it, and I currently have it as a template method because of that, is I need some way to call back into the caller and initialize the pointer, and that is specific to dlib, because dlib has this deserialized things, and both objects which we actually use have to be constructed via this. So we create the object here, but then later we have to call the init function to load the actual data into the object. And yeah, we're just gonna see in a minute how the implementation then of the other class does it. And this is all the code we went through. It's just now much clearer. It's just in one place and not like twice, and with different use cases, and where the deleter is used here or as a member function. The deleter itself now is a lambda, which is declared here in the template method, and which is then returned with the unique pointer, and this is responsible for freeing the object when the task is ending, and hence then the resource is again free to be reused in a different task, which is the whole purpose of this pool. And if I go back into the header, we see here receive pointer just gets the lambda as a callback, which is then responsible for calling deserialize in the one case, and in the other case I have to first test if the string which we actually have in the string stream is 0, and if that is the case, I have to load it from the future, and then I deserialize it into the SP object which was given, and in both cases I need to call seekg again to reset the iString stream for the next usage. And if we go in the CPP file of this class, I didn't touch those. This is just now the way it was before. We call it get deserialized frontal faces from dlib, and we actually use this future to asynchronously load this file, which is 22 megabytes, which we just want to do in the background until the pool is needed. And below here you see all the code which is replaced. So this is, as you see, 126 is the last line which is actually used, and yeah, so this is like way over 100 lines of code which we now just can delete. Yes, very good. And if we go back on the header, you can see the header contains now a bit more code, but due to not needing all of this anymore, it's actually also a bit shorter, and we can just delete this code. And with that, the face detection pool, which I also renamed because the old name was from the first use case, and then I had the second use case, and it still makes sense to have this in one class because it's like just in one place used, and then this class should be the central pool for those objects, and it makes it easy accessible, and I have a template to reuse this in any case, and a much cleaner solution than I had before. And with that, we have this fourth episode now, which is great. And you see that yeah, sometimes I will then do a second episode to show you a cleaned up version. Sometimes I will show you code which does something which I don't have in other ways. So this is now the class which is basically the class which has the implementation for the application, and the pool service itself is now just a template which can be reused in other ways. And one could think about also making a non-template version of this receive pointer method to cover the cases when one does not need an init method, which, you know, probably is the case, but as long as I have it in the context where I use it with dlib, I kind of have the policy not to write code which I don't use, because if you write code that you don't use, that's also dead code. And with that, we are through the fourth episode, and thank you for listening and watching again. Also, one short notice, I think that Meeting C++ Live will be back soon. I'm not sure if it's going to happen this month, but in July I have planned some episodes, and also more episodes of Just C++ will come up in the future. So thank you for listening, and thank you for watching. See you soon.